All right, Dr. P back again. And in this lecture video, I wanted to go over just a few example problems for substitution. Now, the typical problems that you'll see will be fill-in-the-blank type problems. So predict the product, or give the reagent, or give the and conditions, or give the starting material. So let's look at some predict products. So here are some examples here. And you can go ahead and pause and try to predict these products yourselves. Okay, now that you're back, let's take a look at them and how you would approach something like this. So the first thing to do is figure out, based on the conditions, whether you're going to get SN2 or SN1. Excuse me. Get a little water here. All right, that's better. So in this first one here, so let's just call this here 1 and 2. So in number 1 here, my methanol is my nucleophile and solvent. And this is an example of a solvolysis reaction. That is, we're reacting something with solvent and we're going to get some kind of bond breaking. Solvolysis reactions are going to be SN1. Okay, if I have one nucleophile and solvent, if my nucleophile and solvent are the same, it's pretty much going to be SN1. The other reason I know that is, and let me just grab notes from last time, what kind of nucleophile is methanol? Well, methanol is a weak nucleophile, and weak nucleophiles won't work for SN2. So I know that it has to be an SN1 reaction. So this guy has to be SN1. So what's my product going to be? My product is going to be, I'm going to replace my bromine with this CH3OH, except I'm going to lose this hydrogen because I have to end up with a neutral molecule at the end. So OCH3. And it's fine to write it like this because this is undetermined stereochemistry here, and we have a racemic mixture. You may want to indicate racemic, or you could write it like this with retention plus conversion. Okay, but we do get that mix of stereochemistry. All right, now number 2, NaI. Well, that simply equals I minus, and I minus is a good nucleophile. We also have DMSO, which is polar aprotic solvent. And then this guy here is a primary alkyl halide. One thing I didn't mention here was that we have a secondary alkyl halide. If we had a primary alkyl halide, getting an SN1 would be trickier. So here's a primary alkyl halide, polar aprotic solvent, good nucleophile. We're probably going to get SN2. So SN2. So I'll just swap my iodine for my bromine, and I'm done. Now I get inversion stereochemistry, but because I have 2 hydrogens here, and the 2 hydrogens are still there in the product, that carbon is not chiral, so there's no chain, there's no stereochemistry to invert. Let's see here. Let's do another. Let's do another one. Let's do a mechanism one. All right, so let's go ahead and do let's try to do this. So let's take a look here. Again, I can look at my reagent here, and so my nucleophile is also the solvent. I have a secondary, but I end up with a tertiary. So this is going to be an SN1 with rearrangement. Okay, I can't do SN2 with a rearrangement, so it has to be SN1. And if I go ahead and add in some hydrogens here, I would see it looks like I'm going to have a hydride shift. So this guy has to hop over there. Okay, so one of those is new. That guy's going to break, and then that guy there is going to be new. And that CO bond there. So let's go ahead and try to work through this mechanism. Okay. Now, do I have any acid present to do a proton transfer? I do not. So my first step is simply going to be loss of leaving group. I'm going to zoom in here. Hold on. There we go. So let me make sure that's still in frame. There we go. We will get loss of leaving group. Now we have a secondary carbocation. Now if I get my hydride shift, I'll end up with a tertiary carbocation. And now my OCH3, or HOCH3, can come in and attack the carbocation. And that's going to give me OCH3H, lone pair, positive charge. Now I need to deprotonate that to get my final product. So another molecule of methanol can come along. And we'll remove that. And now we'll get okay, which is the same as that, just rotated around a little bit. Okay, so there's my mechanism with a rearrangement. So if you see that something has changed in the carbon skeleton or changed in the location of the leaving group versus where the nucleophile adds, you know it's going to be an SN1 reaction because you had to have a rearrangement. And there are more like this in the practice problems. I think there's a mechanism one that is definitely worth doing, and maybe we can even go over that in a Zoom session. I'll keep you guys posted. All right. But those are just a few examples that I wanted to go over. And in the next video, we'll go ahead and start looking at elimination reactions. So until next time, stay safe out there. Bye now.